All right. Let's start with electrolysis. Okay.
Okay.
Mohammed, we have already discussed separation techniques. The separation techniques, you're aware of them, right? We said that when we talk about separation techniques, you're going to find two ways. There are physical techniques of separation that includes separation of mixtures. It includes separation of mixtures.
Mm.
Substances that are not chemically combined together, they can be separated by physical means like evaporation, online, like distillation, both of them, fractional and the simple one, like chromatography, and we have mm, filtration. All of them are physical methods of separation where you can separate mixtures like sand and water, salt and water mixture, and all of those they can be separated. But when we talk about separation of, then we have methods which are called chemical methods or techniques of separation. When we talk
Mm.
about such, we are talking about separating substances that have chemically bonded together. We talk about separating substances that have chemically bonded together, like sodium chloride. The way
Mm.
to separate sodium and chloride, you cannot do that except with this because they are bonded, right?
Mhm.
You can only do them when there's some students they say, sir, when you are going to put sodium chloride in water, when you put sodium chloride in water, the chlorine and the sodium are going to separate. They are going to dissociate, right? In ions, making sodium,
Mm.
right? But are they really separated? No.
Mm.
Once you're going to bring them out of water, once you're going to remove all the water, they are going to come back together, right? They are just pseudo separated in water. Uh, they they're not actually separated. So in order to separate such substances that have chemically bonded together, combined together, we need to have chemical methods, and one of those methods that we have in our course is electrolysis.
Mm.
All right, you
Mhm.
understand this point now? All right, let's go
Yeah.
back. When we talk about electrolysis is a process of using electricity electricity to break down or decompose a compound, right? We were talking that the separation technique for mixtures. So chemical methods are basically separation techniques of compounds. You understand? So is a process of using electricity to break down or decompose a compound or separate
Okay.
a compound. All right. These compounds in electrolysis are generally used as in molten form or they are in aqueous form. All right. or in aqueous form. And these compounds, when they are being separated, we'll see are going to be called electrolytes. We'll study about it generally, inshallah. We move further. So this electrolysis takes place in an electrolytic cell. All right, it takes place in an electrolytic cell. Now, what is an electrolytic cell? It is an setup. It is an apparatus that is set up for this purpose.
Mm.
All right. This is an electrolytic cell. What are the components? We have source, electric source. It could be battery or anything.
Mm.
Source. It could be electric source. It could be battery most of the time.
Okay.
All right. Then we have wires, connecting wires.
Mm.
Right. Now, the most important of the two, the apparatus is actually the electrodes. Electrodes.
Mm.
When you talk about electrodes, they obviously, number one, conduct electricity. All right, they conduct electricity. They are generally substances that can conduct electricity, like it could be the carbon, it could be metal rods, they could be rods, it could be carbon, or they could be metal rods or plates, and whatever is the requirement of the experiment or the process. So then we have the electrode connected to positive terminal is called anode. Anode. So anode is the one which is connected to the positive terminal. This is anode, right? This one is anode because it is connected to positive terminal. It is going to have a positive charge. You understand? So it attracts.
Yeah.
We are going to see the anode is negative, and it attracts anions. That is why it is called anode, because it has a positive charge, and the anions are the ions of non-metals, right? Can you recall this? So that is why they have a negative charge and they are attracted to anodes. You understand? This point.
mm,
All right. The third point is, or is the electrode connected to negative terminal is called cathode. It has a negative charge,
mm,
attracts cat ions. You see
mm,
where the word cat comes from? It comes from cathode. Cat
mm,
ions that are attracted to cathode, and they are positive in nature. That is why they are going to be attracted to cathode, right? An
mm,
example is going to be all metallic ions. You understand? Then we have then we have the third and the fourth important component that generally is the electrolyte, right? Electrolyte.
mm,
Now, what is electrolyte? Electrolytes are a molten ionic compound or an aqueous solution. Or an aqueous solution. Most of these aqueous solutions are what? Ionic compounds, right? Most of them are ionic compounds. You understand? And salts,
mm.
generally they are the salts, most of them.
All right.
All right. So electrolyte is going to be a molten ionic compound or an aqueous solution, whatever it is. Molten ionic compound or an aqueous solution.
Mm,
Obviously, this molten solution and aqueous ionic compound means that once it is placed in a solvent in water, they are going to dissociate into,
mm,
so they dissociate into cations and anions. If any substance is not able to do that, it means it cannot conduct electricity and it could not be a part of electrolysis. You understand?
mhm,
So what these ions are going to do? Basically, electrolytes allow electricity to pass through them. How? Due to due to presence of ions. We'll study the mechanism, inshallah. When we study the mechanism of electrolysis, we'll study that. All right.
Okay.
All right. We have to keep this in mind. The electrolyte is always going to be an ionic molten compound, or it should be an aqueous solution, because it is only both of them that conduct electricity, right? If a substance is insulating material, and if it does not allows electric current to pass through it, then it is not going to be involved in electrolysis as well. Do you understand?
Mm.
Because we've discussed this, that there can be two type of conductivity: the conductivity that depends upon the movement of ions. Ions
Mm-hmm.
move from one region to another region and allowing the electric current to pass by the movement of electrons, right? And the other type is of ionic conductivity, in which negative and positive ions, they help in completing the circuit. Right? We'll
Okay.
see how. What do you have to write this down?
Yep.
All right. Go ahead, write it down, then we'll move ahead.
Mm-hmm.
All right, so let's move ahead. That how basically we know how does electric conductivity takes place. We know that in order to complete, so basically if you put a battery, there's a battery and there are the electrolytes over there, the electrodes are over there, and there is the electrolyte which is there, right? So if you're going to put a bulb here, introduce an appliance over here, a bulb, right? We'll see that once the switch is closed and it is the current is allowed to flow, we'll see that this bulb is going to light up, which means that electric and the circuit is being completed, right? This means that the electrons are moving from the here and maybe here and then here, and then they're going all the way to the positive terminal. This is how like basically a circuit completes. It completes when the electrons, they move from the negative terminal to the positive terminal, right? You understand this point? Something like this should be going on, right? Yes, Mohammed, do you get it?
Yeah.
Right. So how does this play? What happens when? So how does this place takes place in electrolysis? We know when you're going to when you look at electrolysis, we sorry, let's let me make. So when we talk about what happens, how electricity is passed through the electrolyte, basically when you look at it, the let's say we have sodium chloride, right? A
Mm-hmm.
solution of a sodium chloride solution, right?
Okay.
Not a solution. Let's make it simple. Let's say that we have a sodium chloride, molten sodium chloride, molten, which is in liquid form. All right. So we have a cathode. We have a cathode and we have an anode. This is positively charged and this is negatively charged. And we have molten sodium chloride. When you have a molten sodium chloride, it means that Na and chlorine ions are basically randomly moving around. They are not in their lattices anymore. They are randomly moving around, right? So when you're going to come pass the electricity through this circuit, you because this being a negative, this being a negative electrode, the sodium positive ions are going tend will tend to move there, right? They will be brought nearer to this negative charge. Once they get to this negative charge, they are going to accept the electrons that are coming from here. So the sodium is going to generally deposit by the wall of cathode as it accepts an electron. Do you understand? Are you getting this point?
Mm-hmm.
So this so sodium atoms are coming here, they are accepting electrons, they are attaching themselves to electrons, right? And they are depositing over here once they get those electrons. Similarly, there are chlorine ions which are also randomly moving around. So when this becomes a positively charged, these chlorine ions are going to move towards that, right? Once they
Mm-hmm.
move towards that, they're because they have an extra negative, they have an extra charge, an electron. They're going to pass this electron into the cathode, into the anode. You understand? They're going to pass this electron into the anode. So these electrons are going to be moving towards the positive charge. So if you look at it, obviously this is not really taking, this is not, there is not an actual movement of electrons that are taking place from here, from here all the way to here, but still it is creating the same effect, that the number of electrons that are being accepted by sodium over here is going to be the same, because there is same number of chlorine ions. So it is going to be passing the same number of electrons to the positive ion, to the positive terminal. Do you understand? So this completes the circuit. This is how the circuit is actually complete. You understand this point?
Yeah.
But if they were not mobile, if you think of them, if this sodium and this chlorine or whatever are there, because this is because there at the moment there are no other ions, just these two. If they would not have been mobile, if they would have just in a solid state like this, they would not have conducted electricity, and they would not have been able to move to these to these electrodes, and the circuit would not have completed. Is this real?
Mm-hmm.
Are you realizing this?
Yeah.
So this is how basically how the electricity is being conducted, and this is how the separation actually takes place. You understand?
Mm.
This is how the separation takes place, because sodium is being attracted to the cathode, because it is a cation. It is being accepted to cathode, where it gains an electron, creating an effect that the electrons are moving from, they are coming out and moving along. And on the other hand, the chlorine is actually delivering its electron to the anode and depositing over there. So this is how basically sodium and chlorine is going to ultimately be separated.
Mm.
Do you understand this point?
Yeah.
This is how they are generally going to be separated. And they were compounds actually, right? They were compounds.
Yeah.
If you were going to make them solid again, if you were if you were going if you were going to let it be there and make it solid, then what would have happened? They would have become lattice again. You would not have been able to separate them. So now this brings us to an understanding how elements and compounds conduct electricity, right? So the compounds, when we talk about compounds, they're conducting electricity. They basically conduct electricity on as electrolytic conductors, right? As electrolytic conductors, right? And when you talk about elements, metals or elements in general, they conduct electricity as electrical conductors, right? They are metals basically are conducting electricity due to the electron to due to the movement of electrons, right? And compounds are conducting electricity due to movement of ions, right? And they are due to of electrons. Do you realize this point?
Yeah.
How these two are they different? The conductivity. So generally, this is what takes place. Now there are very specific and important terms that we use. So, right. So when an ion, what we have studied over here, when an ion moves to its respective electrode and gives or takes electron or releases or accepts electron accordingly, gives and takes electron accordingly, they deposit on the electrode as they are turned into their elementary form. All right, as they are turned into their elementary form, like, and their oxidation states oxidation states
Mm-hmm.
become zero. All right, either by gaining electron or giving electron, whatever it is. Like
Yeah.
sodium would have uh, gained 2 electrons and become sodium solid on cathode, and chlorine would have lost 2 electrons on anode and become chlorine gas. So whatever is taking place, if you look at it, the end results are always what? That they have turned into their elementary form, right?
Mm-hmm.
Zero oxidation states. So when this takes place, it's called discharge. Discharge. What is discharge? When or gaining or losing process on an electrode. It's gaining
Mm-hmm.
or losing of electron on the electrodes or
Can we leave it up
at the
until here
electrodes.
today?
All right, we'll keep it till here, inshallah.
Okay.
You need to keep this term in mind. So what do we mean by all of this? We mean that sodium is being discharged at a cathode, and we meant to say that the chlorine was being discharged at anode. Now
Mm.
we inshallah study the actual process of photosynthesis by the examples that are there in our specification, inshallah, right? Each one of them
Okay.
in the coming class. All right.
Okay then. Assalamu alaikum.
Wa alaikum assalam.